And welcome to everyone to the first team design show of Digital Plan. What are we going to do today? You're going to present the task that you have been working on for the last 2 days. I hope you have been working very well during this time, and I hope you're all okay and you have presented a very good work. So now we have, it's a pleasure for me to welcome our jury, Jasper Ross, former VPS of Vice President for Services of BEST, Ricardo Jimenez, also a professional electronic engineer in the field in Altran, and Cesar Vasili, that is part of the topic group that have prepared the task for you, and they are the ones that are going to judge you and see and say which are going to be the winner team for this task. I hope that you have all the rules of the task clear. First is presentation time. As I already said to you this morning, it's going to be 8 minutes for you to present the task. And once these 8 minutes have finished, you have 1 extra minute that there will be a subtraction of points. But at 9 minutes, we are going to cut off your presentation. Be careful because in the 8 minutes, it's already starting to penalize. Then for jury questions, we also have 8 minutes, and also to the jury at minute number 9, we're going to cut them. We are sorry for that, but understand that there are too many teams, and we already have to move on so that this. I hope that you have worked very well. Now we are going to say what is the now we're going to say what is the order of the teams, so that you already have. I'm seeing here that you're having some technical problems, but okay, so we continue. Then the order of the they don't understand. Okay, so the order, I'm going to say like the order of the teams, okay? So first, the first team is going to be Spigoli Vivi, okay? You're going to be the first team. Second team is going to be with Iten. Third team is going to be engineers. Fourth team, Motse Nie Nankapleg Alejako. I'm sorry if I pronounced it wrong, but it's a very difficult name. Fifth team is going to be Michelin. Sixth team is going to be Oh Wow. Seventh team, Dictionary. Eighth team, Wannabe Engineer. Ninth team, Solid Tongue Works. And 10th team, Grow Logging. So now you know the presentation order. So thank you very much. And now you're going to be, you have also the order in the chat. So first, you're going to present your task. Also, I don't know if the jury wants to say something before we start. If you just want to say something, please. Yeah, now you can talk.
Okay, I will just take the word. I just want to congratulate you all. You work a lot, and I hope you have a lot of fun with this topic. And I'm really eager to see your work. Good luck.
Okay, so I don't know with lost person. So if any of the jury, if anyone else from the jury wants to say something, in the meanwhile.
Yeah, well, can I talk for a little minute?
Yeah, sure.
Yeah, it's just to say it's a pleasure for me to take part of this event, that it's taking part in this difficult situation for us all. I'm very happy to be part again of the ABEC project, and I'm sure we're going to see some magnificent work, and I'm very willing to see what all of our students have to say.
Exactly. For me too. I don't know if you're aware of the situation in Belgium and Germany these past days. We've had our fair share of flooding, unfortunately also with some casualties there. So this topic is actually very much up to date. I think that many of us could have used such a life capsule. So I'm very interested in finding out what kind of solutions that you have, what might actually work, and good luck to you. And most of all, enjoy this.
Okay, so thank you very much to our jury that is now going to see your work. So now it's the time for you guys to have to present your work. So ask what you have been done for this 2 days. I hope they are going to be great. Like I've seen some projects of people and they are like quite good. So I want to see more and see the presentation of all of them. And please, now it's your turn. So we will start, as I already said, with the first team. That is going to be Spigoli Vivi. So now the floor is yours, guys.
Hello, everybody.
Now,
One moment, we are going to share our video.
Okay.
Here.
Can you see the screen?
Yes, okay, thank you. Hello, everybody again. We are Spigoli Vivi team from the University of Naples Federico II. And our prototype name is Jack in the Box. And we will discover our prototype's name later. We used and adopted an RFLP approach. So starting from customer need and functional requirement, we arrived to a physical prototype, or maybe in this case, we arrived at a virtual prototype. So we list the customer needs, and so we underline the keywords in order to understand better our task, in order to satisfy what our customer needs. The first phase was the brainstorming phase, and we used the flower technique that we learned during a creativity session on the first day of this event. In this way, we could understand better our task. And we use indeed more and more sketch in order to evaluate our idea. The preliminary analysis was the comparison among different concepts and shapes. And among different shapes and structure, we decided the simple parallelepiped compared to inflatable shelter or sphere or extendable cube, because it is at the same time able to withstand large loads, not only nuclear, but also thermal and mechanical, and it is in particular feasible, and it is cost effective. In this way, in this slide, we can see how we could integrate our Jack in the Box prototype in a room in general, or in particular in a bedroom. So let's move to the description itself.
Yes, the first thing that we did to understand the measures of our prototype was to understand which were the standard dimensions of people. In particular, we looked for an average man and an average woman. And so we used these dimensions to generate our first prototype. In particular, we used the software Jack, this is why Jack in the Box, to understand if these dimensions were able to have 3 people inside of the capsule during the time that during these 3 days. And we found the perfect dimensions. So we arrived to our final prototype, where you can see the dimensions written in the lower part of the slide. Then moving on, we looked for something that was easy to transport, easy to assemble. In fact, we wanted that our prototype could be constructed using only simple parts that had to be connected with bolts and nuts. So it is feasible, and also using simple parts, it is also cost effective. So all the parts earned a high price. Then we can move to the living cell, the part where the people has to stay during these days. The first part, this living cell is made of fiberglass to make it lightweight, wood for the places where people can sit, and aluminum for the ventilation system. Now we did 2 lateral seats with gavons to optimize the space. These gavons in particular had to contain all things useful to survive. For example, an oxygen tank with masks, an emergency radio, a first aid kit, water, MREs, and we also thought of introducing a 6-point harness to prevent the injuries of the people inside the box.
Okay. One of the most important part of the living cell is the ventilation systems. All the components useful for a ventilation system are in an aluminum box position on the top of the unit. Inside the box, we have the standard components of a ventilation system, but with the main component that made able a normal ventilation system to work also in an absolutely closed cell. The main component is the filter made of potassium dioxide that is able to convert carbon dioxide into oxygen. In order to protect the cell that we have seen that is made of easily breakable materials, we add an outer shell. The outer shell is made of structural steel. It is reinforced by rectangular beams. The fact that it is made of 2 different structures make us able to have a space between the inside and the outside of the cell. And we use this space to have a space with air that we know that is a very good isolator. But we also add two layers: a thermal insulation made of technofiber, useful for the thermal insulation, and a layer made of polystone D that is able to protect the cell from nuclear radiation. And we also add two support to make helicopter or crane able to rescue the cell in a difficult situation.
Then we analyze our structure using FEM analysis. For carry out our analysis, we used a simplified model of the structure made of only 1/4 of the structure, because for computational time and for simplicity of the analysis. The first thing that we analyzed was what would happen after an earthquake when all the debris are on top of our structure. So we put a vertical load on the roof, and we verified that the tension, the stress in the structure were very low. We tried to apply bigger loads, and then we discovered that our structure was robust enough. Then we tested what would happen if our structure was 5 meters deep under the water after a tsunami, applying pressure on all the other walls. And we discovered that in this condition we were safe, because steel have a yielding tension of 300 megapascal. We are, in this case, we have only 261. Then we tested a landslide, so applying forces on the vertical and horizontal walls, and we saw another one more time that we had only 7 megapascal on the walls. So thank you for your attention. That was our project. Good luck to everyone that follows us.
If you have any questions, we are here to answer you.
Okay, so thank you very much, guys, for presenting this prototype. Seems very interesting. So now we're for the questions of the jury. So please, one of the members of the jury that wants to ask, if any of you want to ask something, it's now your turn.
I have a question. How can I open Zoom again?
What do you mean?
How can I exit from the condivision?
It doesn't matter. Okay, it's okay.
You can click here.
Okay.
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 No problem. If you have any questions, we are here to answer.
Okay. So Jasper is going to be the first one from the jury to talk.
Yes, thank you very much for your presentation. Thank you also very much for your work on finding a solution for this. I would first like to focus on the matrix that you've made to analyze the customer requirements. How exactly did you proceed with analyzing these different requirements and with putting access everywhere?
Okay. So from the task.
Okay. So first of all, we use the first half of the first day only to analyze the task, the requirements of the task. So we in the presentation we only put all the difference between the geometry of the cell. But after that, the geometry of the cell were chosen by another other analysis that we made of between ourselves to understand what we want. So the thermal insulation, the nuclear insulation. So
we compared also all the ideas that we had, and we saw how all the ideas could fit with the customer needs. And we choose the solution that could fit more customer needs as possible. So we decided to use this structure that is simple because it's not so innovative, but it's effective because it can prevent from a lot of different types of catastrophes. Yes, and this is why we decided to follow this path.
But we did more and more analysis apart from that we showed before.
I don't know if we answered the question.
You indeed gave me some more insights. Thank you for that. But to make things more concrete, let's take a look at, for example, you've analyzed the ball concept, the circular concept of pot, if I remember correctly. The rightmost column might be interesting to show that here as well. If I remember correctly, you did not indicate that this model could withstand a tsunami. How exactly did you end up with that conclusion? Which parameters, which information did you take into account to make that judgment?
We test the structural resistance of our cell, putting on all the outer surface of our structure a pressure that you will encounter in 5-meter depth of water. So we saw that the outer walls will not deform enough to break the structure. And then we, as you can see, maybe we didn't say it during the presentation, you can see the only door, the only aperture to the outer world is a very big door, like the ones they are in ships and submarines that you can close, and it prevents water and anything to come in.
We can show again if you want.
I think that will be fine, given the limited amount of time that we have here for questions.
Okay.
Okay, I just want to add something. Do you think if your device is built from steel and assembled with bolts, do you think it will be able to keep the water outside during a tsunami?
Obviously, the main the main things that we use to assemble are nuts and bolts, but obviously to make it waterproof, there will be other materials along the joints to prevent water to get inside the structure.
Okay, thank you.
So I have a couple of questions. First of all, just like Jasper asked before, how did you test it, your structure, to the performance it will have to an air attack? Have you studied the capacity of energy absorption of the structure?
Sorry, can you repeat?
Yes, I mean, if we consider an air attack, I guess a bomb air attack, yeah. Have you tested your structure in this situation? So have you tested probably the capacity of the structure to absorb the energy of the explosion or the withstand of the forces? Or
Okay, we thought that in case we designed a capsule like the task asked to us that has to be inside a building or inside the normal house. So in general, it's not it's difficult that a bomb arrive directly on our cell. So the load that the cell has to is probably the same of the earthquake that has all the broken bridge on our cell. So this is why we don't have a specific analysis on the air attack.
Okay, thank you. And also you did that in your presentation. And one last question. Have you thought this structure could be used by disabled people? Is it thought for this?
Yes, we thought about that. In fact, we also talked about seatbelts that they can be useful for disabled people to make them comfortable and stable in the capsule. So obviously, for example, a wheelchair can't enter the capsule, but for space problems. But you can position the disabled person inside with the seatbelts, so it is stable and it will prevent the person to have problems, disease, and so on. But because it's an emergency situation, yes, a person can be inside them, but obviously not without all the comforts that he will have outside, obviously.
Okay, thank you very much, and congratulations for your work.
Thank you.
Thank you.
Okay, so thank you very much to all the jury for your questions. We can now, and also obviously thank you to the team Spigoli Vivi for your presentation. It was nice, your model of the life cell. So now we're going with the second team that is called We've Eaten. So now it's your turn, guys.
Okay, guys, so hello. Let me share our screen. Yeah, and we are team We Have Eaten, already done. But firstly about the crew. So first of all it's Orest, who generates air literally by himself. Me, captain, Yuri, our chemist, and Yaroslav, mechanical engineer. So what was our mission? Our mission was to create a life capsule that can save at least 3 people using eco-friendly materials. And we have managed to do that. Our solution is a protection system that looks pretty like a ball or an egg, and you will live your best life there.
Yeah, so talking about the overall structure of our capsule, let's start from the outer layer. So the outer layer is the heat shield. It makes sure that the crew will not be overheated. Under this shield comes the second shield which consists of the steel skeleton and composite glass, and the main responsibilities of this layer is to like keep the structure of the capsule, and also to prevent like damage, like to prevent getting of nuclear damage by our crew. Under this like layer comes the layer of bearings, and the main responsibility of this layer is to always keep the passenger is in the like vertical position, and under this layer comes like the last layer where our crew lives. And like this layer, it also contains seats, comfortable seats, like medicine, air supply system, control panel, which is responsible like for communication of our crew with the like outer world, and also sewerage. Yeah.
So if you talk about the tsunami protection, at first we have an impermeable face destroyer, which are protecting us from outside water leakage and some rock strikes. And also it's made with steel, like it has like 10 centimeters of steel. And also we have a bearing which are holding on the frame, and its supply like that inner sphere is always in a horizontal position. So in case of tsunami, our crew won't be like rotated with high velocity and like that. Yeah, and if you talk about air supply, like we have oxygen balance and other stuff. So in earthquake protection, we also use our first foyer. And what about more about air supply system? We also have the generators, which are using for generating the oxygen from human breathing.
Okay, let's talk about radiation. So as we know, the best like radiation protection from gamma rays is lead. So the heavy like layer of lead. But I found that the composite glass, which consists of mostly of barium oxide, can protect like better than anything. So okay, and it protects from gamma rays very well. Okay, nice. What about fire protection? We found out that the best thing to protect from high heat, from high temperatures, is to cover the capsule with like heat shield that uses like this space shuttles use. So, and it's like works pretty well. So.
Okay, talking about the air attack protection, our strategy was to create as much layers as we can, because each layer will like slow down the shrapnel. So you can see that our system like consists of our layer consists of 3 sub layers. Yeah. Also, our like capsule from the inside, it is equipped with everything that the person needs for the comfortable life during like 3 days. It has comfortable seats with like seats control system, so like passengers can like control the position of the seats. Also, we created utilization system that keeps the passengers clean. And also there is auto opening safe, so that user can open like the fridge or get some medicines with no effort.
Okay, but our task was also to create something from eco-friendly materials. And our first option is to use composite glass instead of lead, as Jurek has said. That really matters. The second one is creating inner sphere with recycled plastic because it's cheap and it's strong enough. And last but not least, yeah, we have an air system, air supply system that protects human exhaled carbon dioxide to water and limestone. Yeah, and that helps to prevent global warming, and also what's more, it's increases kind of comfort.
Okay, last but not the least, it's about cost. Our like capsule made of recycled materials, it could be repaired, it could be delivered by train, so the cheapest way of transport of delivery. Each capsule like don't have expiration date. Like as you can see, like one capsule protect you from totally everything. So it's like it's armored, totally armored, and all electronics can be like made by yourself. So it's very easy.
Okay. Our plan to introduce this all over the globe. Yep. So our capsules, not like on the picture, but they are can be disassembled and reassembled in place where they are needed by disassembling the steel construction and putting together kind of rubber parts. Yeah, and that matters. And what's more, yeah, it would be delivered where it is needed. So thanks for your attention, but we also want one more thing, is to a little bit explain a little bit more how it works. So imagine a joint where there is a sphere inside and another sphere with steel carcass on the top. Yep, and it moves freely inside on the bearings. That's all. Thank you. Do you have some questions?
Okay, so thank you very much, team with Eden. I've seen your website. It seems also very nice. So now it's time for the jury to ask you any question they have.
Okay, congratulations for your concept. It's a really interesting one. I have a question for you. If you would have to sacrifice something in order to make the device cheaper, what would that be and why?
Can you please repeat the question?
So yes, yes. If you would have to sacrifice something, so to put something away from your device in order to make the device cheaper, so more accessible to everyone, what would that be and why?
Yeah, I think that we would remove this composite glass layer because it makes our capsule like much heavier, and yeah, and it may also makes it more expensive. However, like the danger of the nuclear nuclear danger, yeah, the danger of the nuclear attack is like much lower than like the probability of, let's say, tsunami in the Japan. Yeah.
Okay, thank you.
Maybe talking, proceeding there, you mentioned that it will be much heavier with the glass there, and then we're talking about data, a concrete weight of something. In the presentation, that's something where I did not receive a lot of information. You make quite some statements, for example, also that you have there some air pockets. So because of that, it's not going to sink into water. Obviously, you need more than just air pockets. The equations need to match so that something floats and doesn't start sinking. What kind of, or to which extent did you simulate aspects, and to which extent did you calculate the claim that you make in the presentation?
Could you please repeat the question? We have some kind of bad internet connection.
Of course, no problem at all. You make a lot of statements in your presentation, a lot of claims. To which extent have you calculated these claims? Have you simulated it so that the claims that you make are actually truthful and not just assumptions?
Okay, so about heat and radiation protection, we have gathered that information from kind of scientific articles with deep investigations and plots how much material is needed to protect from the given level of temperature or radiation. If we talk about the pressure resistance or kind of earthquake resistance or something like that, we have run a simulation on the empty, just our steel pentagonal construction with a pressure that is equal to, for example, kind of a wall falling on it, or a little bit more, and that works. Yeah, and these simulations were run.
Yeah, maybe like to sum up, I should also like mention that no members of our team like had any like experience with 3D designing. Yeah, so it was like hard for us to create some like some hard tests and some complex tests. So we like basically we
simplified it. Yeah.
Yeah.
And used simple forms like that pentagonal construction itself, not the whole of a sphere.
We leaned on like real scientific notations, so scientific articles. So and some of them. So in this like investigations, science use lead or glass. So and we decided to use glass because lead you have to like use very much lead like to protect yourself from the nuclear gamma rays. So it will make the sphere very heavy. So and also very expensive. So it's like one hand you have a heavy and cheap sphere, in other hand you have like expensive but a light and totally transportable sphere. So we decided the other one.
So, and from my side, one last question. First of all, the idea of the model is very interesting, but I see it quite complex. So how do you think if someone buys the capsule or receives the capsule in case of need, and for example, is someone that doesn't have a specific formation, specific tools, specific knowledge, how do you think how easy would be your concept to assemble, to really receive the capsule and well, make it real, or will it be pre-assembled? Have you thought about this possibility?
Yeah, we have thought about that. So you're true, it would be really uncomfortable and maybe in some way hard to assemble that if you don't have any experience or the right tools. And our capsules are capable of transporting pre-assembled. Yep, that's just a feature to disassemble them and assemble them. And it will be possible, for example, to move them from one country or from one continent to another, disassemble it, and then reassemble it there on the stations or kind of, I don't know, factories there locally in order to reduce the cost of transportation.
Yeah, so
or shipment.
The main point is that like we like divide the capsule into a few pieces just to transport it, but like for example, if this capsule reached the destination, then it should be like assembled again, like with the qualified people, and after that, like people can use it. Like people will, like the users will not assemble it by themselves. Yeah.
Okay, thank you very much and congratulations.
Thank you.
Thank you.
Cheers.
Okay, so thank you very much, team with Eden, for your presentation and your model, and thank you very much the jury for your questions too. So now we're going for the next team. The next team, as I already told you, is engineers. Now it's your turn.
Hello, everyone. My name is Cristina Sandu, and we are team engineers. That my teammates are Vlad, Christian, and Theodor. The task brought forward today was to create a life capsule in order to save lives. And this is how our project, the Protect, was born. Our presentation will cover subjects such as introduction, talking about our concept, our design, and the final cost and implementation worldwide. Introduction. A life capsule is a device who need to save lives. A study conducted in 2020 showed that many people died last year, and over 980 events happened. Now, Christian.
Hello, everyone. My name is Christian. About our concept. Our concept is based on
We're not hearing you.
What's about now? Well, about our concept. Our concept is based on the modular construction of an enclosure designed to withstand a multitude of catastrophes in accordance with international standards. The dimensions of capsule for life were designed so that it could accommodate a family of 3 people for a longer period of 3 days in optimal living conditions, but the average size of a room worldwide was also taken into account in order to make possible install everywhere. The problems to be covered are represented by need to implement such a system regardless of geographical area, reducing cost, maintaining an eco-friendly attitude towards the materials used, implementing a universal protection system regardless of natural disaster, and how to implement the solution. The solutions proposed by us covers a system that is easy to purchase, transport, and assemble, for which most of materials used can be purchased for almost any country. Our system fits in a home and can be also used outside. Eco-friendly materials such as sand and graphite, which are used as a radiation shielding alongside with a reflective paint, can be found in nature. Their processing being considerably less harmful to the environment, remains after fires can be used for the production of graphite, the recycle of high carbon materials. Recycled aluminum is made into an alloy with the use of titanium and chromium, achieving a melting point of 1217 5 degrees Celsius. For reference, an average forest or house fire burns at around 600 to 800 degrees. Vegetable textiles fibers were also used as a part of the proposed system. Starlight was used for the thermal insulation, which has starch as main component. Aerogel can be also used for a higher price, and it's easier to infuse in the inner material coating of the wall. The comfort elements are provided by the chairs with optimal position for sleeping, the backrest being inclined between 100 and 115 degrees, and adjustable side headrest. The seats are also equipped with a height adjustable body harness. The shelter is equipped with a toilet and additional bench that also serves as a storage space. Physical and mental needs are covered. The life capsule has a radio station for environmental measurement, communication stations, GPS and AirTag with e-ink technology for display, clock, calendar, and ambient light from LED lamps powered by nickel metal hydride batteries. That provides continuous lighting for at least 4 days per light. The life capsule provides protection both against natural disasters such as earthquakes, floods, tsunamis, and against air and nuclear radiation up to the 3rd class of resistance. This protection system is equipped with food, drinking water, first aid kits, oxygen cylinders, this being sufficient for at least 3 days. Next, I will invite my colleague Theodore.
I'm sorry, but we're still not hearing anything at the moment.
Can you hear me now?
Yes, now we do.
I'm sorry. I don't know what's going on today. Our design was based on the everlasting concept of modularity. All tiles are constructed in such a way that can be easily put together and, of course, aligned properly without the need of any special supports. After installation, the tiles can be bolted together and forced with cross beams and sealed on all edges with various types of gaskets. The X-frame that you can see in the picture on each tile was inspired from structures using skyscrapers with the thought that it would help with jerking motion as seen in earthquakes. The outer shell frame and compacted ballast made out of sand and graphite uses radiation protection, which is better than lead because of its poisoning properties, and insulating materials made from starlight or even more expensive aerogel are sandwiched together to achieve a high resistance to the elements like fires, floods, and powerful winds, and possibly even from airstrikes that land nearby the life pod due to its high density. With these tiles, the life pod can be built in any desired size, but obviously for the purposes of the presentation, we have adapted it to an average size of a room found in households all over the world. The two-way radio and GPS unit that have been bolted onto the walls for immediate access in case of any disaster are there for immediate communication. We chose to use an AirTag-like device that can hold its charge for days on end while it communicates each user's location, and a low-power usage radio that can transmit information from the authorities. Obviously, comfort is never out of the question, as it is an essential factor in someone's mental health in dire situations. Therefore, we equipped the room with a magnetic chess set, books, and meals ready to eat that include soluble soft drinks, teas, and sweets. The storage unit also houses all these items can be used as traditional bed. Sorry, the storage unit used to house all these items can be used as traditional bed, as it is equipped with a soft touch material on top. And then last but not least, to maintain the structural rigidity, the door was also developed to withstand any form of abuse, whether natural or man-made. The shape we chose to use was determined to have the best properties against radiation and water leakage due to its shape and displacement of its surface area. Thank you very much for watching.
Okay, so thank you very much, team engineers, for your presentation. Now it's time for the jury to ask their questions. So please, if you have any questions.
Okay, congratulations for your presentations. I have a question regarding your prototype. For example, there are some regions with high calamity risk, like Tokyo, where the apartments are really small. Do you think you can fit your device in one of that apartment? Is it suitable for this kind of market?
Probably not. Obviously, as we mentioned before, we tried to consider the average size of room throughout the world, and obviously not all regions in the world can accommodate such a panic room. But we did think that if it were possible, we can annex this life pod to an apartment to serve as a room if need be.
Thank you.
You have included a radio system and also a GPS system.
Yes.
Pretty interesting tools, of course, if they can be used. However, you're also there in that metal cage. How effective are these devices when used from the inside?
Obviously, because we were using mainly metal in the construction, there might be some interference. But generally speaking, from just experience, and because not the entire tile is actually made out of metal, right? Some radio frequencies could pass through, especially radio and especially radio, which is like lower frequency than Wi-Fi is.
So just like other teams did before, have you performed any simulation of the performance of your structure in different cases, like in a landslide or under the water in a tsunami?
We have tried to simulate the structures, but unfortunately, because of the tile system that we use, our software crashed every time. We did run a few simulations just on, basic sheets of 10-centimeter metal, and the results were favorable for most situations.
Thank you and congratulations. Very good.
Thank you.
If I might add on that, you mentioned they're favorable for most situations. In which situations is the solution that you present here not favorable?
Anything over 10,000 newtons of instantaneous impact. So about 1,000 kilograms. And obviously, situations where you would have a very small surface area, so therefore the pressure would be higher. So we try to think or to expect that any time that there was an actual impact with the structure would be something that would have a large surface area. Therefore, the pressure would be propagated over the entirety of the surface of the wall. And also because of the way that we built everything, we expected to sort of have like a, I want to say, tightening effect when the walls actually flex in a little bit. Of course, we also have beams installed up on the top of the life pod for such cases.
Okay, so thank you very much, team engineers, for your presentation, and thank you very much to the jury for their questions. So your prototype was also really nice. So let's go for next team. Next team is Team Motsenien Alespaco. I'm sorry for this pronunciation because it's quite difficult, but I hope it's not that bad. Now it's your turn, guys.
We can't hear you.
Sorry, yeah, we can't hear you, sorry.
Can you hear me now? Okay, I can see that you can. Okay, let me go back. This is our solution, the life pill. It is constructed like this. This is a structure. It is made of two shells, an outer shell, an inner shell. In between, there's a water jacket. There's a storage on the bottom and an entrance on the top. It can be on the side depending on how it is placed in a home. The outer shell is made from 6mm rolled strip steel. It is coated on the inside and outside using zinc to prevent from oxidation. And there's a fire resistant cork on the outside to give some insulation. And it is bolted from segments. There are 14 segments in total. The inner shell is also pill-shaped. It is made from 4mm aluminum alloy. There is insulation on the inside, and there are also accessory points here noted with these dots. And it's also segmented and bolted together now with only 5 fragments. The storage system at the bottom houses the oxygen generator. There's a insulation between all the systems because the oxygen generator and the carbon dioxide absorber generate heat. There's also some water and food storage, a mobile toilet similar to one in a camper van, and a place for control electronics and sensors. Let's look at the cross section. Here we have 45mm insulation of styrofoam. Then there's the aluminum. Then there are shock absorbers in the water jacket that make sure that the shells are placed correctly, and the absorbers are placed on ball joints. And there's the steel and cork on the outside. The entrance is built like this, so we have an openable outer cover. If you need to, in an emergency, open this from the outside, this cavity here is filled with water using this valve, and the water is coming from the sides. So it's also the water can be also be routed here. The sides are self-aligning; they are tapered, so it's easy to close. And there's this rubber joint because this inner surface and outer surface are connected here. So this is like an additional place where it can bend. Now for the sensor, there are of course LED lights, some GPS receivers, GSM radio transmitters of antennas routed to the outside of the shell. There are sensors for the oxygen and carbon dioxide. And there are smart vents to monitor life functions of the people inside, and the Geiger counter. For the food storage, there is a lot of conservable food, high energy food, some drinking water, but also first aid kit, maybe Lugola liquid. There are mountable accessories. So there are safety belts for the impact. There are nylon string ladders if it is placed vertically. There are hammocks, so you can put the hammock always in parallel to the ground. So even if it's slanted, you can sleep on a nice parallel surface. And the toilet can also be mounted. And there are also soft foam helmets for the impact, some blankets for sleeping, and an entertainment system. And now for each of the dangers, we wrote what is this connected with, what kind of damage we can expect. And with fire, there is, well, we have the cork insulation. So it should for some time provide insulation, and it should not it should not ignite. Then we have the water jacket that has very high heat capacity. So for example, 8-hour fire, which is normal house fire, this should not hit above 40 degrees. So people inside will be fine. And the inner insulation provides the coupling from water. So even if the water gets hot, on the inside it's colder. And for earthquakes, the ductile outer shell prevents fracture. It's made from moldable steel. And then we have shock absorbers, and the water jacket. They can negate the impact and make sure the forces are even on the whole structure. Yeah, and then the GPS systems can help rescue forces. And for the tsunami, we have positive buoyancy. And there it is fully sealed. So even if it's for some time in water, there is no water ingress. And when it comes to landslides, the whole structure should provide collision, and it should not, with crashing force, people inside shouldn't be harmed. And when it comes to airstrikes, the ductile steel sheet and the water jacket should negate any impact of sharp shards that are generated during explosions. And also we have for radiation, well, the big water jacket is what we have for radiation, and also we have the metal plates, and this should significantly reduce any radiation. And when it comes to challenges that we faced, it's this transport. So all the segments are at maximum 70 by 180 centimeters, so they should fit in a door frame if you want to build it into a house. And most of the weight is in form of water, so it doesn't require production or moving, and it can be it is available locally. It is very cheap too. And when it comes to air management, we have two technologies. We have CO2 absorption using sodium hydroxide, and we have oxygen chemical generators, just like in planes or in submarines. And both those technologies don't need any electrical energy. So even with an electrical fault, they should still work. Okay, and for availability of the materials, we don't use any uncommon materials. We only have steel, aluminum, water, maybe cork, some styrofoam. They are also quite eco-friendly. And most of this can be produced locally. And for salvageability, we have GPS, radio communication, just like we said, and it can be painted fluorescently, so it can be easily found in debris. Here's the links for the photos, and thank you.
Okay, thank you very much, guys, for your presentation. So now it's time for the jury to make their questions to your prototype. So now I give them time.
Shall I start? I have some questions regarding the ergonomy and the comfort of your solution, because at the beginning of your presentation, I've seen the capsule situated in a vertical position. So I thought you were thinking of 3 people standing on their feet for 3 days, and I think that's not very much very comfortable. But after the presentation was on, I saw your examples were with the capsule in a horizontal position that might be much more comfortable. How have you approached this topic of the comfortability of the people inside the field, and also just recovering the first question I asked to the first group, if you ever thought about disabled people using this kind of solution?
So for comfortability, we thought that in any position it is laying on, then it should be enough to turn around or sit. So we have the hammocks that can be placed always spirally, and the toilet that can be placed like this. There is storage on the top, but you can easily reach it even if it's upside down. And we thought that if we increase the space too much, it will be the weight will be so much. So when it's an emergency, you don't really need that much of a comfort. It is enough to live for 3 days, and it will be fine. You won't be harmed because you're sitting there. And for the disabled people, we thought about maybe some kind of winch-based lift, so they can be lowered into the opening.
Okay, thank you.
Thank you very much for your presentation, also your design, all your work for this past days. How did you come to this pill-shaped design? What considerations did you make? What simulations did you do to identify this as the optimal approach?
Yeah, well, vertically, a ball is a perfect shape for this because the forces are equal, but these balls are quite hard to make, and well, it wastes a lot of space, and also, we can have the same, let's say, strength by making it longer. So it combines a cylinder with a ball, and also it's easier to transport or to fit in a room because a ball would be much higher, so it will be above the height of a single room. So we would have to have like a bigger rooms just to place the ball inside.
Okay, thank you very much.
Okay, congratulations. I also have a quick question for you. If would you live in a city or a place with a high calamity risk, would you buy such a device for yourself, and why?
Yes, I will think so because we designed it, and it also depends of the rescue forces because a lot of time you will be covered in debris, and we think that it gives you a lot of protection from crashing and we mainly focus on feasibility and costs and possibility to make thousands and hundreds and millions of them, but we think it provides enough protection against things like burying by debris or maybe crashing by in a building.
Okay, thank you.
So I have one last quick question. I saw your device depends a lot on water because there's a high layer of water covering the device. Have you thought about any alternative to use this device in places with lack of water or that they are suffering from desertification? Or well, that makes water a very, very valuable resource for living?
Well, you could use anything that's really dense because density is what stops radiation. So maybe sand or like very moldable concrete or something, maybe even dirt or maybe some stone shards. Anything that is that will give it mass but won't make it less moldable.
Thank you.
Okay, so thank you very much, Team Motseni and Affiliates Alejako. So I think your presentation and it's quite nice design. And now it's time for the next team. It is called Mission. Now your guys have to present your work. Hope to the slide as the same to all of you. So come guys.
I'm sorry, wait just a minute. I can't see it. I can't see it. Okay. Okay. Hello everyone and dear juries. We are Mixen from Yıldız Technical University in Istanbul, and our group members Emine Bektaş, it's me, and Veysel Erdal Kıran, Aliyan Kılıç, and Yunus Emre Yavuz. We can start the presentation. First of all, we decided some analyses about the shape of our life cells. And the analyses, firstly, we started our work by deciding what the shape of the life capsule will be. It's the important point. In order to decide on the shape, we made an analysis by applying pressure, 3 prototypes on SolidWorks, via SolidWorks. And we applied 10 or between 100 G-forces from certain points to 3 figures. You can see the picture, this 3 prototypes. And as a result of our analysis, we decided that the shape named Icosa, this shape, is more resistant to pressure. And at the same time, we have stepped outside of the classic round taboo round you can see in the internet. And Icosa has managed to disperse the pressure applied to it. And you can see emerging stress points in the red. The red point is the stress point for the pressure. This divide.
So why did we apply the pressure test? Because of the life capsule designed in the moments of tsunami, earthquake, and landslide, may remain under the under the ravel. In this case, the important thing is that a capsule maintains its shape and doesn't transmit damage to the inside. In this way, it can protect the lives of the people inside. Next. Layers, is the pressure test sufficient for protection? No. So the outer covering needs to be robust of every situation. You can see the layers of the design in the next picture. First one, aluminum. Second one, for radiation and fire. Third one, steel. Now let's explain the layers.
Aluminum and steel, the purpose of using two different metals is to reduce the impact of the crash by hitting the aluminum first. Then it's aimed to protect its form by encountering stronger steel. The durability of the design is important for tsunami, landslide, earthquake, and air attacks. Nuclear radiation. Other issues we need to be protected from is radiation. We offer a solution for these problems. Normally, the first solution that comes to mind is to consider plating with lead for protective from radiation. However, as a result of our research, we discovered a newly produced thermoplastic material. Turing Kimya is a Turkish company. They produced the world's first lead-free radiation protection shield using boron minerals. Its name is anti-rad. This material is 1/8 lighter than lead and does not reflect radiation back like lead, absorbs it. It is also less costly and environmentally friendly. Fire hazard, one of the layers that the outer layer will be covered with is for fire hazard. We decided to use glass wool in one of the coating for fire problem. What is glass wool? Glass wool is a heat insulation material. At the same time, it provides fire safety. Glass wool has temperature resistance in the range of -50 and +250 degrees. The temperature of glass wool products without binder can reach up to 500 degrees.
Anti-impact system is a system with sensors to protect the life capsule against external impacts. Next. It's very common for this capsule to encounter extraordinary situations. One of them is rolling as a result of the collapse of the place where it's located. You can see the inner and outer part of design. In this regard, sorry.
No problem. In this regard, we have brought a solution to design. Yes, the life capsule will be two-layered and its interior will be a complete sphere. And between the two, there will be balls placed and 3 different axes. In this way, just like a bearing, do you know bearing? And the inner part will not move while the outer part moves. Principle of working the bearing like that, it's provide the balancing and stabilizing. Yes, thank you. Yeah, this is the center of the gravity under the sphere, under the room. Okay, in internal structure of the life capsule, what is included the life capsule? You can see the like a room and 2 beds because at least 3 days, maybe we can more than days. So 2 doors, one doors maybe can be closed by rock and etc. Rubbles. So 2 doors and the toilet and provisions. Provision part includes some conservation foods, maybe some waters and first aid kits, etc. Maybe some clothes and communication system. Communication system includes SOS button. We explain the next spaces, and under the room, under the floor, some oxygen tubes and tanks, and the waste water tanks, and for pure water tanks. We won't want to mix these tanks. So, and some batteries, because least 3 days, maybe can more. And we sometimes need some energy for electronic devices to communicate and the outside. So
And
like
also,
that.
and also diesel motor and motoring support the battery system.
Yes, this is the SOS button. We based on the Mercedes-Benz. This application is currently using the Mercedes-Benz. Thanks to the application, the driver communicates with the company. With the button, it's an emergency situation. Without the internet, based on this application, you can reach the company. You can see the simulation of the disaster area, like the red area. That's it. Thank you for listening.
We wait for questions.
Okay, so thank you very much, Team Mixen, for being here and presenting your prototype. So now it's time for the jury to make their questions for you. So, jury, your time now.
Yes, thank you very much for this presentation, for this creativity and the solution. You've clearly chosen for a more luxurious setting, especially also if you compare to other solutions. The accommodation that you have there, it's very similar to what I have here at home, maybe even.
Yeah.
Why exactly did you choose for that more luxurious concept?
When we thinking cheap and safeless life capsule, we located in house, but it's not radical, because in apartments have a lot of people, and it don't need to one capsule to one house. When the hunger, we located a larger life capsule, and house tube led to transfer peoples, but our design is comfortable and a bit expensive, but I hope explain our thinking.
I'm sorry, but it's not yet completely clear to me what you exactly mean and what kind of, well, reasoning was behind this design choice.
Okay, I try to explain again, because the apartment have a lot of houses. It means hundreds of people. It is very individual system. For it's not fit to hundreds of people, because in houses the rooms very small, and it have to small, but apartments down the apartments have larger area, and I see now I don't see any preparation for this. But if it's wanted, we design for apartments, and it will be very effective and less price. We aim to specific and very safety life capsule, and with relax, because the people's need very a lot of things, nutrition, we see, etc. We so in small life capsule, it's meaningful because in 1 week these people live relax in our life capsule, because their health very important. Health not survive. Psychological health very important, and I believe, and my team believe, in this capsule they don't harm for psychological way. Thank you.
Okay, thank you very much for the second and more elaborate explanation. I think I got the main points. For an apartment, more people, a redesign would then take place, and attention for the mental health of people when there is this very stressful situation, that they are put at ease in this concept. Thank you very much.
Thank you.
So just taking back this concept of your, well, luxurious and with a big space for the people inside. Have you? I haven't seen in your presentation the topic of transportation of your solution and the assembly of it. And well, regarding the concept you have, this would probably be well, a difficult topic to
yes
cover. So
I'm sorry.
Yeah.
I'm sorry.
Please.
Okay. Actually, we think that we can separate the triangle or the pentagon. You can see that, but it's not. This time is up, so we can simulate the presentation. Maybe we can separate that triangle and the pentagons, and we can bring together. And maybe we can disappear in the inner side, yeah, and we can divide the two parts, and we can assemble, but we can put the presentation.
Okay, thank you.
I want to just add something, and you can see the principle of the working. This the video. It's the way for the disabled people. Maybe we will share. Use it.
Thank you very much for the consideration. Thank you.
Thank you.
Okay, so thank you very much to Team Mixen. Now it's the time for Team OWOW. Best of luck for you, and please present us your work during these 2 days.
Hello, welcome to our presentation. We are Dietert, Polly, Anka, and Marie from Team OO from the University of Ghent in Belgium. We are very happy to present our concept. As you can see, it's called the Table of Life, to eat and to survive. Oh no. Marie will start with the description of the problem. Next, Diedert will explain our concept. Then Polly will clarify all the materials that are used. And then I will give a recap of all the highlights of our concept. Now I give the word to Marie.
Due to the climate change, one natural destination will color tsunamis, earthquakes, and etc. We could become deadly situations. A lot of people died in natural disasters. Casually could be avoided by providing good protection, or design will keep families together. Almost every house has a table for dinner. Table is also the place central in the house, so it's always close by. It is a place that you remember, have nice family moments.
One of the many things you're taught as a child is to hide beneath a table during an earthquake. We want to build upon this first instinct to make a table, the central piece of furniture, as a safe haven. This design will protect your precious family against collapsing buildings, fires, floods. When a disaster happens, we rush to the table and jump underneath. There's enough room for 3 people, even humans up to 2 meters tall. When everyone is inside, you close the roller shutters, will make the box waterproof. Next, you pull the cord to inflate the pillows, and they will pop out like airbags. Some seatbelts are attached to these pillows in case of heavy movement. They won't slam into each other. The pillows also help to make it more comfortable. And together with some small windows, they keep you safe. As you can see, the middle of the table is supported, so you won't simply collapse on the load. To ensure good air, we installed an oxygen tank and CO2 scrubbers based on solar lamp to remove carbon dioxide, because you never know when you might be stuck in the water or beneath a ton of rubble. Naturally, a small medkit is present with some iodine tablets against radiation, and although food and water isn't needed for 3 days, we have the space, so we just included it. The table is also equipped with a torch you can charge with a hand crank and a small radio station to communicate with the outside. On the outside is also a capsule you can activate with human sense, so search and rescue dogs can find you.
For the materials we used for the top table, bamboo. Bamboo is the new steel. They say it's like a really future wood. It's very ecological because it's the one of the fastest growing plants, and also it converts more CO2 into oxygen than other trees. It's also very strength and stronger than other woods, and like I said, it's like the new steel. It's also used in buildings. We use pressed bamboo, and there's a high density because it's pressed, and that will lead to fire resistance. And also because it's for a table, it fits perfect in any interior because it's a beautiful wood. For the frame of the table, we use bio-based fire-resistant composite named Duplicor. It's bio-based and it's made from bio-waste. It's also very ecological. It's also fire-resistant according to the highest Euro fire class, and it's lightweight. So it's good for when there is a lot of water, it will not sink. Also very strong. It is used in buildings who are earthquake resistant. So it's a very strong material, and it has a high impact strength, and it is easy to form into a table. For the little windows, we have some little windows on the outside of the table for keeping contact with the outside situation. For the windows, we use polycarbonate. It is durable, and you can see through this plastic. Yeah, it has a high impact resistance, so it's also very strong, and it can handle extreme temperatures, what makes it very good for this design.
Our design is customizable, so it can fit in every house. It's available in different colors and is adaptable for bigger families. The tables are easy to assemble. They are lightweighted and stackable for efficient transport. Because our concept is both table and life capsule, it's cost effective and durable. As Polly mentioned, the used materials are ecologic. The table can protect you against extreme warmth due to the materials and a thin layer of air between the materials. And all the materials are fire resistant. And the box is also waterproof and very strong, so it can protect you against flood or falling debris. This was our presentation. Now we will answer your questions.
Thank you.
Okay, so thank you very much for your presentation. It was really nice to see your prototype. So now it's time for the jury to make questions about your project. So Yuri, come on, your turn.
Okay. Thank you for your presentation. It's a really interesting concept. You said before that you will inflate the bags, the pillows, as the airbags. But for the airbags, they have a really high force when they inflate. Wouldn't be that dangerous for the people inside?
It will more work like a soft pillow, like an air pillow, and not like an airbag. We will use the chemical reaction for inflating the air, but we will make it more dense and not so strong and not so hard.
Okay.
I will then go next. Thank you very much for this presentation and for this, well, straightforward, I think more simple idea. Very nice to see that. Now I'm a tall person, 1.93 m. So dimensions, they matter to me because otherwise I don't fit. What kind of dimensions did you envision when talking about this concept?
Well, a normal table is also 2 meters long, so for a tall person, you will fit in the table. And also, this design is adaptable for bigger families or for 1 person or 2, or for 5 persons. So, yeah, you can make it bigger or smaller as you want.
To build upon that, there should indeed be some people inside, and those 3 people inside. You also would put there a lot of supportive elements. Let's say there are, for example, the oxygen that you mentioned, if I remember correctly. Of course, all of that also takes in some place, especially if you want enough oxygen to last 3 days. That's already quite big. Where exactly would you store that in this concept so that it's as space efficient as possible and also easy to reach from your position in it?
Well, the oxygen will be stored in the floor. As you can see, it's quite thick, so there's a lot of space to store oxygen. And all the other elements like the ration, food, the med kit will be stored in the side walls with a small panel you can pop open.
Thank you.
So from my side, if I understood correctly, the main structure of the table will be made out of bamboo. Is it right?
Yes, only the top, like the surface on the table where you eat on, is from bamboo, and all the rest of the table, like the frame and the sides, are made from the composites.
Okay, because I thought that using wood in case of emergencies like fires or floods or tsunamis or whatever might not be the best idea, because well, wood is combustible and also absorbs water. I don't know if you have thought about this issue, or if you would find any alternatives, or if you think there will be no problem with using this kind of very eco-friendly material also in your solution. I wanted to know your opinion.
Yes, you can give the wood a special treatment against some that it's more waterproof. But bamboo in natural form, it's a really stable wood in if you watch water shrinkage or swelling. It's really stable.
And it doesn't burn like other wood.
Yes. And especially because it's pressed bamboo, the high density will lead to fire resistance. And of course, everything can burn down at some temperature, but it is fire resistant for tree. Yeah, we chose this because it's fire resistant and other materials aren't.
Okay, thank you very much, and congratulations.
Thank you.
I'd like to ask one more question. And this regarding, well, you covered survivability, let's say, of your device against most aspects, except air attack and nuclear a little bit. So could you please elaborate on how you rate your device's sustainability against nuclear attacks and air attacks, please?
Yeah, we thought of some to hoe zeg je lood?
To include some lead into this composite, which will make it better suited for protection against radiation. And for the air attacks, it's basically the same for an earthquake. You just jump into this table, close all things, and you'll be pretty much protected against collapsing buildings and flying debris.
Yes, and also you can change the box to do the region where you live, because when you live near a radiation source, you can include lead, but if you live not nearby, you can skip that part of the design.
Cool. Thank you very much for your answers and explanation.
Thank you.
Okay, so thank you very much, team. So the next one is going to be team wannabe engineers. That's your turn now.
Are we? Is our turn or?
Yeah, wannabe engineers was after visionary.
Okay, sorry, I got confused. I thought you were visionary. Sorry. Thanks, team. Oh wow. Now it's turn.
Yeah.
Sorry, yeah.
Okay, start. Okay.
Okay, do you curious? Great. Firstly, I would like to allow our judges to take a sip of water, just to relax, and after a few seconds, we will start. Okay. So let's start. We are Team Visionary, and we are going to represent to you our ball onion solution. So firstly, agenda. We firstly want to represent what existing solutions are there on the market right now, and then to represent our own. Mostly our implementation, survivability aspects, and the economical ones. So this is a solution you can currently buy, but we think that we can make something better. So we don't like it. We were searching for an inspiration, and we found it in the Zorb balls. We were thinking and asking ourselves, what if Zorb ball wouldn't only have 2 layers, but more of them? It would still function as a Zorb ball. And not only this, if we make a Zorb ball with more layers, we can put any local ingredient, local material into those layers to make this ball survive anything. So we came up with a plan to ship Zorb ball to each of our customers. Zorb ball customer would inflate it, and after the inflation, he would simply put the locally sourced materials into the layers. In our configuration, you can have as many configurations as you want, obviously, just designing different Zorb ball. In our configuration, we would have the first outer layer from the concrete, inner layer with the water, and then inner layer with the isolation from earth. But this is not obligatory, of course. You can fill out the outer layer with only dirt if you don't have any concrete, and inner layers only with water if you expect to use more of it.
So now I will present you the ecological factor. So as you think maybe that plastic is not the most ecological, but actually the amount needed for a sphere like that, it's much lower, like it's 20 times lower than CO2 footprint of an aluminum sphere. So actually PVC is in that way much more ecological than metal. So survivability aspects. We got fire, earthquake, tsunami, landslide, air attack, nuclear radiation, and let's go over them. So for a case of a fire, we designed like our configuration is designed to withstand it. The problem with fire is that you cook inside. So we got concrete, then water, and then insulation. And actually, we have a valve to release the water when it starts boiling. And when water goes from liquid to gas, it takes much energy, so it cools you down. And then you have the inner insulation layer. Then for a case of a landslide or earthquake, you can like reinforce your concrete with steel wires. So the ball maintains its shape during the rolling and stuff. So then we have a tsunami. For that case, we calculated the buoyancy force of our sphere, so it floats. You may think it may not because it's from concrete, but actually it's large enough, it floats. And for the case of air attack, our sphere is shaped like an onion, so it has many layers and the shrapnel and stuff doesn't penetrate it. And for nuclear radiation, actually the only thing that stops gamma rays is thick, dense materials, and this is concrete in our case, and then we have like neutron radiation, which is easily stopped by water, and it's very harmful toward humans, so it's good to stop it. So my friend will explain the rest.
Okay, so standard cabin features are enormous space suitable for more than 4 people. Because of this large space, the air itself is sufficient enough for 12 hours for 1 person. But it is also equipped with 10 liters oxygen tank, which is enough for up to 4 days for 4 people. The cabin is cleaned of carbon dioxide with absorbers made of potassium hydroxide. There are also biodegradable poop bags and backpack full of food. Additionally, you can have more layers in the Zorb ball, which can be used also for different drinks or as a waste tank as well. There is also an enormous water tank, which is located in one of the layers of the balloon. You have a tap for access to the water layer, so you can see that this water has more than one purpose. Then we calculate some costs And we found out that the biggest cost is the Zorball itself, which will be custom made, and we calculate that it will cost around 500 euros. So with all the other parts and materials, the price does not exceed 1,500 euros. So we would like to thank you for your attention, and if you have any question, you can start.
Okay, so thank you very much for Team Visionary for your presentation. Now it's time for the jury to ask you some questions about your topic.
Okay, congrats for your presentation. Another interesting and different concept from the rest. That's why what I wanted to see. So I'm really enjoying this. I want to ask you, how would you fit such a big ball, like you have at least 2 meters in diameter, inside of your apartment, and where would you put it?
Yeah, the apartment is not the best storage space for our ball, but it would fit a sizable room, like 10 square meters, it would fit in it.
We were measuring it and it would fit in our office right here.
And the most important thing is this, that the ball itself, when it's not constructed, it's really small because it's folded. It's just a plastic Zorball, and then you inflate the ball in the final destination. So you just put it in the room. You don't have to put it through the door. You can build it inside the space and then make these concrete layers and mud layers and so on.
So basically, if it's raining a lot, you can just put the concrete in and everything.
Yeah. we didn't test it, but maybe.
All right.
I have a question regarding the equipment necessary to survive, to be put inside your solution. Because if you could please go back to some of those slides where you were talking about the CO2 absorbers or the O2 generators. There was, yeah, it was like that. So I guess all of those features really are not inside the Caminare, because if you can store it folded and inflate it in the place of delivery, how can you deliver as well all of those? And if any of them need energy, or if you have thought about something that needs energy, how can you generate it? Because I haven't seen anything like batteries or a system to generate electricity in your solution.
Great question. Well, I would like to point out that our priority was to make a design available for as many people in the world as possible. So we wanted to exclude all the complicated equipment, including any electronics, which would mostly make the thing more expensive. So we focused to all of the things that you can simply store in the backpack. And we maybe didn't point this out too much, but for example, oxygen tank, you don't really need such a big oxygen tank. It can be brought after the initial build of this device. Also, all the absorbers are not in such a high volumes that they would be would need to implement separate rooms for it, including their way of working doesn't require any electricity. It's a chemical reaction that mostly needs a bucket of some liquid and you throw it in. That would need to be added in the user manual and in a backpack included after the box or with the box.
And for air, we actually calculated that like 2 people would live for at least 3-4 hours without suffocating. Like CO2 would become a problem after that, but even without absorbers or O2 tank, you would live for 3 emergency hours in our tank, in our sphere, Polonium.
Thank you.
Then finally, a question for me. But first of all, thank you for this presentation and for all of your work. You have included a valve from the middle layer through the outer layer to the outside, right? For the stream of the water. You've also included a valve from the middle layer through the inner layer to your living space. What is your assessment of these two valves that kind of connect still the outside to the inside through that middle layer on the safety of your solution?
Well, we imagined one-way valves, and obviously having excess of fumes inside the balls, they would let air from the main living area outside. And we didn't assume that any of them would fail leaving or like pressuring inside or letting any of the outside layers to bleed into the inside. So in short, we always assume pressure inside to be bigger as on the inside, and one-way valves to let pressure from inside direction toward the outside layers.
Do we still have more time to ask questions, or are the 8 minutes passed?
Can you repeat, please? We didn't get this.
To the organizers, do we still have more time to ask questions? 2 minutes left. Oh, okay. Thank you, Sophia. Inflating the whole device and filling it up and so on, is that something that you imagine to do the moment that some kind of alarm sounds that like in 5 hours there's going to be a natural disaster? Or is that really something that you envision to be done the moment that it arrives and you have your device there in place and ready to go for later on?
Like, that depends on your situation. If you can, it's better to like pre-assemble this thing, of course, and then it's your bunker. Like if you want to be extra safe, like you would dig a hole on in your garden and put it inside, and then it would be even better.
One of the things that we want to to remove out of this equation is that whenever you want to have a safe space, you want to make it from the concrete. One of the most resourceful things is to make a concrete mold, and this takes many days. And our patent is actually a removable, easily putable mold that can be realized in minutes instead of days in comparison to the standard solutions. So we can say you can put it when danger comes, but obviously we are planning to sell it to people who would put it up way earlier.
Thank you. To be clear, the mold that you're talking about, it does not exist yet. It's something that you are envisioned that you can create in the future.
Well, we imagine that the shape of a Zohr ball would allow us to make this mold. Yes.
Of course, our PVC would be thicker than just a normal Zohr ball.
Okay, so thank you very much, Team Visionary, for your presentation. And thank you very much also to the jury for your questions. And now it's time for Wannabe Engineers team. So now it's your turn, guys.
Can you hear me, first of all? Do you hear me? Yes, you do. Okay. Okay, a minute. All right. Okay, so our life capsule is called the Life Tent. You see why. These are the contents of our presentation. First, we showed our design, some unique features of it, and how does it cope in scenarios like fire, earthquake, etc. So we got some inspiration from the Apollo capsules, which went to the moon and then landed on the sea. And so an overview of our structure. It's what you see is made of made out of 1 millimeter thick steel. So we thought 1 millimeter thick would be a fine balance between not being too heavy but also being stiff and sturdy. And we'll show you now a preview of how it unfolds actually. So this is the design we made in SolidWorks and a short video of it. You'll see more of how this works later. Can I? No. Okay, so, oh, I forgot to mention actually, this entire thing, tent or capsule, is, okay, you can see it has mesh on top, on the floor and on the roof. And the entire thing is actually surrounded by a skin we designed. A skin like a thick fabric. And the way we have sealed it to the structure is that we actually have made some rails. So if we see closely here, this is the section of the ring, the outer floor ring, which you see, which you can see here. So it has a groove, and so what our skin is. The outer layers are fiberglass. We'll explain why later. The skin inside we'll also explain later. But they sort of connect and fold around steel cable. This connection, this seal between steel and the skin is what we believe to be waterproof. I've actually tested in real life. So yeah, this is how we made it. And now Eugene will explain you how exactly this works.
So on the screen, you can see how it unfolds again in a GIF. These pipes that are one inside the other, the tubes, they extend. And there is this clicking mechanisms, actually 2 of them. The way it unfolds is just one motion, it's instant. One has only to pull this ring upwards, and the automatic clicking mechanism will click these buttons outside through the, so on 4 of the poles, you can see it has 8 pipes. On 4 of them, the system is automatic. So once you pull it up to the height, it will click automatically, and the rest of them are manual. So the user has to use these rods through holes. They are more sturdy than the automatic ones, and in case something goes wrong with the automatic, there's always the manuals for backup. Back to Feather.
Okay, so here I'm back again. So what about the roof, or where you also can come inside to? It's a roof / hatch. You can see the design here more in 3D, and it basically has a hatch with a mesh on top of which we also have there's a rail on the ring, so we can also put the skin there so that it's airtight, waterproof, and a lot of extra features you'll see later. This is a scrap sketch we made, and yeah, so this is how it works. It has some hinges where the pipes that Eugene mentioned connect, and also a hinge outside, which is made to, yeah, so that you can open the hatch. And So we have put high temperature black silicon on the ring of the roof. So between the hatch and the floor and the roof ring, because that can resist up to 1,200 degrees Celsius, and which also makes it airtight. And the locking mechanisms we didn't get to design, but they are basically these briefcase hatches you can see on the upper right corner, on the inside, of course. And now the skin composition that we talked about. Well, on the outside, it has 4 layers of fiberglass, and 1 on the inside. Yeah, fiberglass, which is in fabric, which is fabric cloth. So okay, this is fireproof, and you see later in use. Then we have nylon films around the ceramic wool. Ceramic wool is actually ceramic wool. Sorry, it's very insulating. It can resist up to 1,200 Celsius. And okay, it's not 4 + 1 layers. That's a typo. But anyway, it's toxic for humans, so that's why we have wrapped it around nylon, which nylon also gives us some waterproof and airtight characteristics. And finally, we have also some lead apron, basically the lead composite that they use in the suits when you're taking exams with X-rays. So that we found out that protects you against 90% of the radiation. So that's very good. So supplies included inside, because you also need to leave somehow. Well, we have got this very portable toilet. As you can see, it folds into this nice suitcase. And we may also include extra poop bags, because you may need them. Then water. We concluded that we need 12 liters of water for the 2 adults and 1 child for 3 days. And look, if you're starving, if you are in a disaster, this will surely make you survive for more than 3 days. And then we have got 3 kilograms of military biscuits, high energy density, dense biscuits, basically. And we concluded that this was that we needed 3 kilograms of them. Here are some pictures we found. Then this is optional. This is more expensive, but it may be the only option to survive inside when there's a fire outside of the capsule, so you actually cannot renew the air inside the capsule. So you will obviously need oxygen. We found out that each human needs 400 liters per day. Anyway, through calculations, we found out that to survive for 12 hours on this, you would need this canister, which has a length of 65 centimeters and a diameter of 11 centimeters. Not too big, it fits there. Then, so we also made a CO2 trap, and about that, Jerry's going to talk, which is our chemical engineer.
Okay. As you can see, it says optional in the top right. This is far from optional. This is a typo. In order for humans to survive, a concentration of under 1,000 parts per million is needed. And when you exhale, that concentration of CO2 is 5%. So when you exhale a lot, this will build up inside the chamber and the people will suffocate. In order to prevent that, we use the solution of sodium hydroxide. And in order to capture as much CO2 as possible, we made it saturated. And we calculated that we need 15.5 liters for the 3 days that the 3 people will survive. But this is far too much to put inside the thing we made. And also very heavy, actually about 22 kilograms.
So I'm sorry, Team Wannabe Engineers. You have finished your 9 minutes, so I'm sorry, but we have to cut your presentation so that you are not going for too long. I'm sorry, now it's time for the jury to make their questions about your presentation. So please, jury, I give you the word.
So that was unfortunate. Anyway, I'm waiting.
Okay, I will take the word if no one does. For me, you didn't convince me regarding the protection against earthquakes or landslides. How exactly your device will behave when something heavy will fall over it? Because you have some flexible bars that just click in there.
Okay, so first of all, the structure.
This kind of pressure.
Yeah, so it's just 1 millimeter thick steel. We didn't want it to be too heavy. We wanted it to be portable and transportable, which we obviously can showcase in time. But okay, it cannot withstand a building falling on top of it. That's for sure. It's not a tank. It's not a cabin like the other teams made it. But but we thought it would be enough. We obviously do not recommend that you put it inside your home. If you could, you would put it outside so that the building doesn't fall on you or on a balcony. But it is strong enough to, we believe, to resist a lot of debris. And that skin we used is also those 4 layers of fiberglass outside are really strong. We tested that. We actually bought fiberglass and also tested waterproof, the fireproofness. But we believe it's enough. Let's be honest, it's not as withstanding as the other cabins would be, but it has other disadvantages. Advantages, sorry. Yeah, that's the answer.
Thank you.
Thank you very much for your presentation, for your idea as well. A quite interesting one, especially quite easy to set up, I believe. However, once you put on the tent, I assume that, well, you do that while being on the outside, right? Not while being on inside?
No, that not necessarily. Like one person can actually, okay, when it is folded, it's on the ground. One person can open the hatch, stand inside it, and pull and push it upwards. So so that's for one person. The other persons would have to climb inside it. Okay. Oh yeah, and so we didn't tell the dimensions. It's actually the diameter of the floor is 2 meters, and it's approximately 1.6 meters high. 16. Sorry.
1.16.
1.16. Okay, 1.16 anyway. So it's not too high. You can climb inside it. Kids certainly could, but yeah, that's how you would use it.
Okay, thank you for that elaboration. Now, other stuff like the toilets, like the oxygen tanks, they would also need to then go through that hatch, I assume?
Yeah, about that, we designed the tent not to fold completely flat. So actually, when it folds up to it still has 15 centimeters of height inside. Therein, we could store the oxygen tank, the water, all the supplies included. And I actually have a picture of that, how we would do that. So this is upper views, let's say, from the cabin of how all the supplies would be stored when it's folded. Those fit inside. And this way, everything is tied up with seat belts, actually, which persons could use then inside. We didn't mention that. And you could also roll it on the side. So yeah, those supplies would come included. It wouldn't be needed for our clients to buy them.
Okay, thank you.
Any other questions?
Not from my side. That's okay.
In that case, topic group would kind of request that you show us the slide number 4, if that's not a problem.
Slide number 4. Could you elaborate?
Yes, overview of the structure.
This overview, okay.
Okay, thank you. And if you would not mind showing us slide number 21, transportation.
So it's not a picture of something, but we just, yeah, we have written some things that it folded, the dimensions of it folded. 42 centimeters. Oh, okay. Okay, yeah, the outer height, let's say it's 42 centimeters. The inside height is about 15 centimeters, what I said earlier. Sorry.
Yeah.
But yeah, do you have any questions on here?
Okay, and just one last question. Which one of you is Phaeton?
I'm sorry?
Which one of you is, I believe the name is spelled F-A-E-T-O?
Yes, me.
Yes. Do you know what was the last time to edit the task on the schedule?
I'm sorry, can you repeat?
Do you know the schedule? What was the last time to edit your task?
So to edit our presentation?
Yes.
Yeah, well, we actually, okay, if you spotted actually, during their presentations, we found we were a bit jealous of the name, so we just changed the title from Live Capsule to Live Tent. That's true, we changed it actually afterwards, but it's a very minor change.
Thank you. We have no further questions.
Okay, thank you.
Okay, so thank you very much, team one of the engineers, for your presentation, and thank you very much also for the jury for their questions. So now it's time for the next team, that is Solid Thumbworks. That's your time.
Hello, everybody. Can you guys hear me? Nice. Let me just share my screen. Hello, everybody. Our team is Solid.Works, and we're gonna present our design for the life capsule. Hopefully, we're gonna have an approach where we're gonna express our creative process, our inspirations and objectives, design concept, and CAD execution. We firmly believe that we created a cost-efficient structure that is capable of securing the safety of 2 adults and 1 child for at least 3 days. It is equipped for a lot of possible disasters ranging from fire to nuclear radiation. In this presentation, we will talk a little bit about our specific solutions next, and we'll also talk about our design implementation and our implementation plan. In our concept, we achieved the following. We created a life capsule that ensures, as I said before, the safety of 2 adults and 1 child. As you can see, you have plenty of space for them. We made the seats custom made to a normal adult. It can fit in a normal household. Fun fact, this is our faculty.
Now I'm going to talk about more about the structural issues here. We've chosen the aluminium, an aluminium to the structure because we are playing with safety of people, and we chosen a sturdy structure, a ball-shaped structure. The aluminium joist was justified because it has a good weldability and a relatively low price regarding its strength. We've compiled some materials which have good and excellent weldability, as well as high yield strength, using Grantus as EduPack software. We've come up with these solutions, and we have opted for the aluminium because it was what seemed the most cost-efficient one. We've run some simulations on the main frame using the Inspire software. These kinds of simulations made with this lack of time are not totally accurate, but we can see that we have a sturdy structure that is able to withstand some big amount of force. So we can firmly say that this is the safest structure, one of the safest shapes that we can have to protect the lives of the occupants.
And now regarding the walls of the prototype, we chose a 4-layer sandwich structure. And with this, different layers will protect against different hazards. So analyzing from inside to outside, the first layer is a contact surface between the rollers of the main frame, and it's made from steel. The rotation of the cage will secure through rollers that will allow free rotation between the inside structures, the cage, and the layers outside. This mechanism is key in case of a flood, a tsunami, or whatever, a rollover of the product, so the occupants are upright. In case of fire, it is an issue for the survivors, therefore isolation is a problem. We chose cork as our isolator, as it has a low conductivity. However, we will still, we'll talk about this once again in a few slides. On top of this isolation layer, there's a structural layer made of aluminium, and here are some mathematical module that we came up with the thickness of the cork. Lastly, to cope with radiation, we put an outer layer made of lead to shield from nuclear threats and all kinds of radiation. The glasses are also made of lead or ever composites of lead. So
yeah, so the passengers have air to breathe. We choose to install an high-performance air purifier. So it has multiple layers with different purification capabilities that offers smoke protection and radiation protection. Here in this slide, we highlight 2 mechanisms of our solution. We have an inflatable device, and then we have the door edge. We have the edge. We did a simple mechanism to close the door. It can be used from the inside or from the outside of the capsule. So our design concept has a lot of storage. We put a radio, so it's possible to communicate with outside. So we put a place to drink water, then space to storage food, some life vests in case of an emergency, and we install a toilet. Our design have a clean water tank underneath the floor, as well as a dirty water tank. It has 2 batteries underneath the floor as well, to give some energy to a LED light that is on the top. With all of that, our concept ensures 3-day survivability, basic needs for everyone, communication need outside, and a lot of storage.
Talking a little bit more about our sustainability and eco-friendly material option, we chose cork, but why cork? First of all, we're from Portugal, and we're the world leaders in cork producing. And cork is the only tree that can have its bark removed without actually killing the tree. So it's a very good material to use. We implement it in 2 ways, in the seats and in the cork isolation layer. Talking a little bit more about the practical implementation of our prototype. We devised some phases. First, we start with the prototype, then we would devise some future tests and to achieve certification, have an initial investment of 1,000 units, and then achieve mass production worldwide. We chose the first place of action, Sierra Leone, that it's a place that normally is really affected by natural disasters. We did a spreadsheet of the cost of our materials and manufacturing processes. We chose a lot of, try to choose the most cost-effective options all the time. Our prototype costs us 7,000 euros. With 1,000 units plus shipping and logistics, we would need an initial investment of 10 million, and we would try to get sponsorship mainly by UNICEF, and ONU NGOs. To conclude, I think we can safely say that we achieved our objectives, and we strongly believe that our design choice, I think we as a team would feel safe in a natural disaster in our prototype. Thank you for your attention.
Okay, thank you very much for the team Soliton Works for your presentation. It was really nice to see your designs. So now it's time for the jury to see what do they think and ask them, ask you some questions. So please, jury, ask whatever you want. It's your turn.
Congratulations for your presentation. It was really nice. Have you thought though about ways to transport this capsule, because it looks like it's very solid? Will it be like mounted by the customers, or it will come in this form?
Personally, we think that if you have a structure that is as nuclear resistance, fireproof, that can't be built at home, and it's pre-built. But in terms of the shipping, it probably had to be by plane or by train.
Okay. Thank you.
Thank you.
So thank you very much for your presentations, and congratulations for your excellent work. I would like to ask you about the budget and the cost of your solution. As I've seen, probably the cost of implementation in a country with really needs of this kind of solutions, it's very costly and would depend on the money from outside sources.
Yes.
Would you have any plan to make your solution a bit more cost effective or a bit more cheaper for deploy it in countries with special needs like Sierra Leone?
Yeah. It's kind of hard because of the type of technology and choices that we try to achieve, but we actually try to think about that in our methods of designing. Just to show some points, in our materials, we always try to choose a little bit that trade-off between cost and performance, pretty much. And in the types of manufacturing, it's the manufacturing in itself of the life pod. It's simple. The main frame can be welded. The steel tubes the aluminum tubes can be extruded. So we chose those ways.
And we could make some changes to the structural aspect as well if we see that some region from one of those countries as a typical disaster that is more prone to happen, we can make like some changes to the prototype itself. Like we can remove some of the side tubular to decrease the weight or the price itself. We could remove the bearing mechanism, so it would be a lot less complex and it would reduce significantly the price. So we can make those changes a bit, those details. Like if we don't, this region doesn't have tsunamis, or it's very difficult to have a tsunami, could remove those options, so it could have a more cost-efficient solution.
We could also do topologic optimization to try to cut on the material. That could be an option too.
Okay, thank you very much.
Thank you.
And last question from me. Thank you for this presentation. Thank you for the beautiful designs there as well. Very visually appealing and very, very clear. Now I'd like to focus on the HEPA filter. So it might be interesting that you go to that slide there, because you mentioned that it serves there, it's there as a fume filter for the case of a fire, as a radiation filter. Why would you expect that there are fumes inside this device if there's a fire outside?
Well, I believe that the fumes, or we thought that the fumes came from outside. So the filter is an outside to inside. So basically, it's our intake. The risk is that the intake can be polluted. So like with fumes or with radiation particles and so on. That's why we used so high standard filters.
And it's like multi-layered as the sandwich solution, like one layer for one solution.
Okay, good. But now I get it. So you have this whole metal casing on the outside, but then there's a gap somewhere in it with the HEPA filter in. So there's still this connectivity between outside and
yes.
inside. Okay, thank you very much.
The topic group would request you to please show us your last slide.
This one?
No, the last one. Okay, thank you.
Thank you.
Okay, so thank you very much, Team Charlton Works, for your presentation and the jury for their questions. So now we're going for the last team before finishing this first TD show. That is the team roll-up. The floor is yours.
Thank you very much. So please, Jacob, share your screen.
Working on it. So can you see the shared screen?
Right, nice. Let's start the presentation.
Okay.
So welcome everyone. I hope you are not tired yet. Welcome to our presentation about our life capsule, and we are named our project Diogenes. We are a team from Brno University of Technology. I'm Philip, team captain. Kubo is responsible for CAD design. Lucas is our technical consultant, and Dominic runs the simulation and also is CADing. So now I will pass my word to Lucas.
Okay, we take inspiration and named our solution after ancient philosopher Diogenes, who lived in a barrel. When we started the work, we looked to the maps of natural disasters, areas that tell us that threats are there.
We focused on three key features.
Oh, sorry, I have muted my microphone.
Sorry.
We are focused on these three features. We use this dimension of ISO container that allow easy transport. Another advantage is the modular design, which can be configured as needed. And of course, the Diogenes is a self-sufficient solution. Because we used these dimensions, it can be transported by ships, trains, and trucks. And we also want to help our planet. So Diogenes is made of recycled steel and plastic.
So for basic equipment, we wanted to include water tank and also a wastewater tank, chemical toilet. For food, we rationed it for 3 days. We calculated that the 3 persons will need about 600 kilocalories per day. We also included a recycling unit because the whole structure is airtight. And for emergency reasons, which are the disasters, we have emergency radio beacon and also iridium phone antenna attached on the body because there will probably not be a cellular network. Also, first aid kit is included in the storage with some red mats and basic first aid equipment. So now you can see the Diogenes in its beauty. It's a tube which has a good physical resistance. Here you can see the living quarters, which we will explain later. And the whole structure fits the dimensions of the ISO container because the chimney, that's what we call it, is separated, can be separated, and can be folded inside. Then there is another section which we'll explain later. So this is our design. The tube is composed from steel and then surrounded by a layer of concrete, and then comes the recycled plastic.
So our power supply was approximated to last for more, at least 3 days. We use car batteries, which are easy to use, easy to replace, easy to charge, and don't have too many problems with charge decaying over time, at least when compared to something like a lithium-ion battery. These batteries are used to power air recycling, the emergency beacons, and of course the lights and general electronics inside. These batteries are stored within the living quarters, within the beds, which also function as seats and as a table. Here you can see the cross-section views of the entire body, so you can get a better feeling for what the inside would look like and for the size. The living quarters, as I already said, contain 3 beds, which also function as a table and seats, and would contain some general entertainment to last for 3 days. And the technical section contains a chemical toilet, a water reservoir for drinking water, and storage for medical supplies, food, and so on. Also, the floor would be a wastewater tank.
As we mentioned, our design is completely modular. The cylinder is solid, and then you can place inside everything you want. So, for example, if you want to last longer than 3 days, you add extra batteries, water, and also, in case you want to go outside during the radiation problems, we can include CBRN suits, and for even longer period of time to survive, we can add man-powered generator. Next slide. The structure is, we believe that the structure is rigid enough to survive any damage, and in case of fire, tsunami, and landslide, and it can be buried in ground for extra protection. That's the chimney, or it can be mounted that the exit is sideways. According to next slide, airstrike, the rigidity should be also enough. We didn't consider atomic nuclear strike because there you are probably not able to survive, but we considered radiation catastrophe like nuclear power explosions. And the whole container is sealed and airtight, so no radiation dust will get inside.
Okay, manufacturing options. First option is made it from scratch, from steel tube and profiles cage. Tube is coated around plastic insulations, and second option is modify ISO container for transport the gases. Cut out hole for entry chimney, coating with plastic insulations, and install the equipment inside.
So
for protection is necessary buried underground.
We also render it to look like IKEA because it should be easy enough to install and modify. Next slide. Yes, so now we will answer questions.
Okay, so thank you very much, Team Grolog, for your presentation. Now, as you said, it's time for the jury for doing the last round of questions of today. Jury, come on, that's not just your turn.
I can start. Thank you for this presentation. Thank you also for well, using very clear designs, and so that it's easy for us to envision your solution. I would like to focus on one particular part, maybe even detail of the presentation, namely the batteries that you would like to use. Because you mentioned wanting to use car batteries because of their high availability at many places, and it's true because cars are these days everywhere. However, a problem with car batteries is that even if they're new, once every 2 weeks, you need to restart your car. Otherwise, they just drain completely and you can't keep on using it. So what kind of answer do you have towards this
well, the whole structure or the shelter capsule would be connected to house power, which will keep the batteries fresh and ready. So in case of the disaster, they will just disconnect because probably the power went out. So it will be connected via some cables to normal power grid, and in case of emergency, it will disconnect. Or it can be still powered by external power if the power lines stand. Hope that answers your question.
Yes, thank you very much.
Okay, thank you for your presentation. It was really interesting. I have another question for you. You have such a big device and highly customable, if I understood right. How you see this device being mass produced? Do you think you can have a solution that fits most of the people, or you will customize it for like each one, for each customer?
Well, it depends. Probably the basic model, if we can call it, will include the things we mentioned, but on special requests, we could add some layers of protection. And also we would focus on the disaster which occurs in the area of the distribution. For example, if you are inland, you probably won't need protection against tsunami.
Okay, thank you.
I have one question. It's more like a curiosity, because in the video you saw of the assembly or the explosion of your capsule, I saw the part that it's upside the cylinder, the one that you go inside the cylinder, that you can remove it and store it inside the cylinder. Is it right?
Yes, it's right.
Yeah.
That's
So
for
this is
transportation
the
purposes.
purpose of this solution is for transportation, I guess. Yes, just for transportation.
Yes, because when it's folded inside like that, the entirety of the shelter fits within the confines of the ISO container. So you can ship it stacked on one another without the entrance interfering with the other containers.
So okay, and then have you considered that this assembly, this part, could be a problem in order to bring the solution to the client? Because I guess this part would be quite heavy, so probably one person can do it on his own. Maybe needs some machinery, a pump or something like that.
That is true, but machinery is needed to install something like this anyway, especially if we use it as intended underground. We have to bury it, so we have to already use some pretty heavy machinery. So lifting something like that should not be too much of a problem after lifting the entirety of the construction.
So your concept needs some installation after.
Yeah, we didn't want to compromise safety for ease of installation. Of course, it's an important thing, but if we can ensure almost absolute safety, it's of course more important than that. So burying something like this in the ground is a lot a lot more sturdy, a lot more protected, especially from, for example, radiation, which can be stopped by, I think, 1 meter of dirt already stops most of radiation.
Okay, that's clear. Thank you very much, and congratulations for your work.
Thank you.
Thank you.
Okay, so thank you very much, Team Grolog, for your presentation, and thank you very much to the jury for their questions. Now we are finished with Team Design Show. Thanks to all of you for participating. I hope you have liked the team design and the competition. If you have anything to say, any comment or whatever, you can always write us. We are always approachable, so please write us if you have anything to say. We are very happy to have this competition. I hope you are enjoying it. You are enjoying the format, the setup, and all this stuff. I hope you're enjoying the tasks and how they are presented. And for the jury, if you want to give us some words, just some final comments about what do you think about the topic presentations, now I can give you the word so that you can make a brief recap if you want.
Sure, you can give me the word, or I can just take it. Yeah, I mean, congratulations to all the teams that we've seen here in this afternoon and for these 2 days. I think you've been working quite hard. We've seen very beautiful results, very creative ones, some very close to home, some others more ambitious. But I think it's also a topic where you could, within some constraints, be quite creative with the approach that you're going to do. We've also seen some very nice simulations being done at testing everything as much as possible in this online environment, which is kind of a big power of digital technology. So from my side, I think that the other jury members agree with this. Congratulations. You can be proud of yourself, of the work that you've done these past days. And I wish you a lot of good luck the upcoming days, because it's far from over and everything is still possible. Thank you very much and have fun.
Okay, so for me, it was amazing, all this experience, like seeing you work all the time from yesterday and today. It was an awesome experience. You had like a lot of different solutions, and I was hoping that before the competition that you will not come with the same idea, and I saw that sometimes you compromise safety, sometimes you compromise cost, and every team has something different, and I really enjoy it, and I want to congratulate you all.
Yeah, well, in my case, I just want to sum to the to the words that my partners in the jury already said. It's been a pleasure. It's been great to see all the work you've done during this day. It's great to see how the same problem can be solved differently, how the ideas of you all are different, are very enriching, well, it's like engineering, it's all about, no? It's like giving different solutions. I hope you've enjoyed this competition and then you want to come back to it. And I would also like to thank to the organizers and the core team that they are also doing a fantastic job. And it's great to be here with you all.
So thank you very much to the jury for coming today. It's Sunday and you're here in the afternoon, so it's really nice for you to be here. Also, thanks to all of the participants that are here competing with us now. It's like really nice to see you all at the Remo, working, enjoying it. I hope you liked the competition. I actually love team design. I think it's a very good competition, even though this year we cannot have you here. the CAD software allows to have like some beautiful designs, and like I hope that someday you will be able to actually like build them physically. I hope you liked this kind of different theme design online. I think it's been really nice. It's also a very good experience for us to see you here present your creativity, and it's, I think, a really very interesting for us to see what you've created. So just now I wanted to do a quick reminder for you for tomorrow. We have a free day, so please, in the morning we don't have any activities at all. So please rest, get up late and rest, because we still have half of the competition left. So you're having another team design task Tuesday and Wednesday. So tomorrow, and also in the evening, well, afternoon, evening, we've got some social activities that are not mandatory, are voluntary, but we actually strongly recommend you to come, because you're going to experience more the social part of BEST. That is also very important, and that due to the pandemic is harder to deal with, but we want to share a little bit about our culture, like about Madrid, about Spain. And the same as it would have happened is you could have came here to visit the city or to visit the Spanish culture, where we have prepared 3 different activities for you. One is like cooking some Spanish dishes, also singing some Spanish songs, answering some questions about Spain and stuff. So I hope you like it. We have prepared it with care. So tomorrow afternoon at 3, we can meet at the link that they will send you, so that we can have these social activities. So by now, it's everything for today. I also remind you, if you don't come tomorrow, that on Tuesday we are having again the same schedule, and we are meeting at 9 on Tuesday. So please come to the next working hours. And for today, we are over. So I just want the jury to go to a breakout room we have prepared for you. So we will open a breakout room for you, where you can think about what the teams have done, and you can like put the punctuations and say who's the winner of this task. So, and for the rest of you, that's the end of the day. So thank you very much for being here, and goodbye.
I want to ask a question.
Oh, yes, sure.
Was this for Mars?
What?
Was this for Mars? Maybe.
What do you?
Life capsule.
What do you mean? I didn't get you. Sorry. Okay, like, can you repeat the question, please?
Maybe next year's life capsules on located the Mars. So I asked a question.
So I cannot understand you. Please, like, can you talk a bit louder or something, because I can't hear you.
Okay. Is this we will see in Mars? So I asked for it was for the Mars.
The Mars? What do you mean?
Mars planet.
Oh, that we will see in Mars.
Yes.
Yes, sir.
Okay, thank you. We have some troubles, I think.
Like I
with microphone, so I don't want to waiting others.
Okay, I don't understand like what you're meaning. So if you don't have any other question, I will say goodbye to all of you. and see you tomorrow, actually. So goodbye.